Hey guys, we are doing chapter 22 today. This is the last chapter in Unit 5, so this will sum it up and you'll be able to do study guide and portfolio and all that good stuff. Chapter 22 is on comparing two proportions. So it says comparisons between two percentages are much more common in the real world setting than questions about isolated percentages, which is what we've done so far. We often want to know how two groups differ, whether a treatment works better than a placebo or whether this year's results are better than last year's, things like that. So you will still have to state a null and alternate, but they're going to look different this time. So you will state your null hypothesis as P1 equals P2. You have to state what P1 and P2 are. There are two groups in these situations now. You have to identify which group is which. And then your alternate is going to be that the first is less than the second, first is greater, or they're not equal. Again, this is depending on how the question is worded. So this time, instead of putting a value there as P1 equals some number, it's always, every single time, going to be P2. You just have to decide what sign goes in the middle. So when you're trying to find your mean and standard deviation, your mean is simply that P1 equals P2. Your standard deviation is the difference between the two proportions, and that is our formula down there. Notice if you're doing standard error, it's the same as it was. It just has the extra piece because you're going to be comparing both of them. So you have to add them together, then square root. All right, so let's do this example. I'm going to be writing it over here. There is only one example in this, so I suggest writing it down with me. It says, do snoring rates differ for those under and over 30 years old? The National Sleep Foundation asked a random sample of 995 U.S. adults about their sleep habits. Of the questions asked about snoring, 26.1% of the 184 people under 30 snored, compared with the 39.2% of the 811 people in the over 30 age group. Is the difference of 13% sufficient evidence to suggest that older people snore more than younger people? So just a heads up, guys, they're going to be using the word typically, significant evidence, and that's how you know you're doing one of these p-value or confidence interval problems. So the very first thing we have to do in a situation like this is state which group is which. If you forget to do this, you will not get full credit, okay? Your work is meaningless if they don't know which one's which. So we're going to call P1 our under 30 years old. And we're going to call P2 over 30 years old. So that would make my null hypothesis in this situation, P1 equals P2. This is saying that they both snore the same amount, okay? My alternate, it said in the problem that the under 30 were 13% less likely to snore than the over 30. So that means I am saying that younger people snore less than over 30 people. Okay, so this is how you have to set it up. You have to state which is which. You said state null and alternate. There's no numbers here. I know 13 was in the problem. We don't use it in our null and alternate. Next is conditions. You still have conditions. They have not gone away. They're not going to go away. You have to write them every single time in context. So the first one is that people tested are randomly selected and independent of each other. Our next condition, there were 184 in the young group. There were 811 in the old group. That is a total of 995. So I need to know there are more than, remember, it's got to be times 10. So 9,950 people in the U.S. And remember, you have to have 10 success and 10 failures, but this time you have to have 10 in each group. So we have at least 10 people who snore and 10 who don't in each group. Each group meaning the younger and the older. Okay, so, there's our information, has our hypothesis. Another way you can write it, this is also correct, I usually don't do it this way, but it's not wrong, is you can say P1 minus P2 equals 0, and that P1 minus P2 is less than 0. I typically stick with what we've already been doing. It's way less confusing. There are conditions. There is a note at the bottom there. It says, note, it is not necessary to have the same amount of people in each group. Okay, we can see that because our young people, we only did 184, and our older people, we did 811. Not the same amount of people, but that is okay. All right, some things it wants us to calculate. This is actually not part of your problem. You are not required to calculate standard deviation, but I want to show you how to do it just in case it asks you for the standard deviation. But when doing these problems, this particular piece is not a requirement. So standard deviation is this giant square root. Now it said we're going to do young people first. The probability of young people snoring was 0.261, which would make Q 0.739, and there were 184 of them. Plus my older people, 39.2% of them snored, which means 60.8 did not. And we surveyed 811 of them. When I put all of that in the calculator, I get 0.0366. Just trying to save some time on the video. You can check and make sure that's correct. Now, we are going to the calculator because we are using yet another test on this incredibly long list. So if you go, oops, not second stat, just stat, test. Okay, this time we have two proportions. So notice you got some choices here. We got two sample t-tests, two sample t-tests, one proportion z-test. We've already done that one. Two proportion z-test. This is where we're at, number 6. We are doing a two proportion z-test. Now, in this problem, it gave me percentages. It did not give me the actual number of people. So you want to make sure you calculate this. So I got x1 and n1. X2 and N2. Now, I know the N's, they gave us that, 184 young people and 811 older people. Now, X1 is the number of them. Now, it gave me the percent. It gave me 26.1%. So I need 26.1% of 184. That's 48. And here, I need 39.2% of 811. That is 318. So when you put this in the calculator, you need the actual number of people, not the percent. It will give you an error if you do this wrong. So here's all my values. I am saying that less than, go down to calculate. Gives you a lot of information. Gives you the z-score, gives you the p-value, gives you your probability of 1 and probability of 2. We already knew those. We have them. Gives you p-hat, and we already knew our n1 and n2. The one we care about is p here. Be careful. P cannot be 4.29. If you write 4.29, they will mark you wrong. Please check and make sure there's not an E at the end. For one, probability cannot be greater than 1. So if you put the probability of this happening as 4.29, you are way, 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 way over 1. So that's a good key that, hey, P can't be over 1, and this tells me 4.29. I need to check for this E at the end. So my p-value is actually 0.00043. Remember, that e to the negative 4 means I move that decimal 4 places to the left. This p-value is less than, remember it didn't give me an alpha level, so I'm just going to go with the typical 0.05. If I am less than my alpha level, that means we reject. Okay? Now, just writing this is not enough. You need to write that sentence, so let's get that going. I need another sheet of paper. We would say, based on this data, we reject the null hypothesis because our p-value of 0.00043 is less than 0.05. Okay, so when you're writing these two sentences, things you have to have. You have to state whether you reject it or retain. You have to state why. Your why is the p-value. You have to have both those things. Therefore, we can say, this is your in context, that people under 30 snore less than those above 30. Okay, you need these two sentences. They have to have all three parts: reject or retain, why, which is your p-value, and what it means in context. You have to have these things every single time. Please do not forget. All right, so here's our conclusion. We rejected our null, so we went with the top one. All right, so if I wanted to use a confidence interval, remember, p-value and confidence interval are two methods of getting to the exact same answer. If they do not tell you which one to use, you get to pick. Most kids pick p-value. I'm cool with that. But if they ask you specifically for a confidence interval, you need to know how to do it, which is why I teach both. So we're going to do the exact same problem with a confidence interval. Okay, again, in our ridiculously long list of tests, we have two proportions, but this time I want a confidence interval. So all the ones that say Z or t-test, that means p-value. We'll get to the t-test next unit. So we don't need that. Here I get to intervals. We're not using those yet. I have a 2-sample Z interval. Nope, that's not it. 2-sample T interval. Nope, because we're not in samples, we're in proportions. We've already done one proportion Z interval. Here we go. 2 proportion Z interval. Okay, telling you, there's a lot of tests up here. We're going to get to almost all of them. So we're doing 2 proportions. There's 2 groups, and it's Z, not T yet, and we're looking at the interval. All right, notice our calculators are really nice, and they copy all of the information over for us. That is super kind of them. So it should already be there. You may need to change your confidence level. This one asks for 90%, so make sure yours says 90. And we're going to go down to calculate. The top line is our confidence interval. Let's write that down. So what does this mean? Here we're going over this sentence. Remember, the sentence is a little bit different than the other one. So you would say, we are 90% confident that the percentage of people under 30 who snore is between, here's your confidence interval. You actually write it without the negatives, and I'll show you why. So it's between, and they're negative, so I got to go backwards. 7.1% and 19.15%. Here's where the negatives come in. It is lower than those above 30. Okay. So it says, does this support my conclusion? Well, my conclusion and my p-value said yes, that people under 30 snore less. Here I am saying yes. My confidence interval says that people under 30 snore 7 to 19% less than those above 30. So yes, these two do go together. So that is, I think, all of them. Yep. So like I said, you need to know how to do both p-value and confidence interval for these. And if you have any questions, please email me and let me know. I'll be posting your work. See you guys.